Hello students, welcome to the fourth lecture on the lecture series on integers and whole numbers. Okay, so previously we were doing some exercise problems, and before that we did what? We did all the kind of concepts and some types of problems that are usually involved in this topic, integers and whole numbers. So what we will do in this lecture? We'll actually be continuing to do more exercise problems. Okay, so that we could get more variety of problems. Okay, so that we could perform better in competitive exams. So let's go forward and start the lecture. So we will be covering exercise problems, and this will be the fourth lecture on the lecture series. So let's start from problem number 1. So two numbers are in the ratio 3:4. If their LCM is what? 72, then find the two numbers. Okay, it is given that LCM. So their LCM is what? 72. So LCM, what is LCM? LCM is what? Lowest common multiple. Lowest common multiple, right? So what we will do? So let A be, so their ratio is this much. So given that, so 3x plus 4x, 3x and 4x be those numbers. Okay, so basically their common factor is x. Okay, so it is given that what their LCM is 72. Okay, so we assume that the numbers be what? 3x and 4x. So LCM of 3x and 4x will be what? 72. That is given as 72 here, right? Okay, so LCM of two numbers is that in the ratio is this, that is 12 times of their common multiplier. Okay, so therefore what? 12x is equal to 72. So x will be 6, because x will be equal to what? X will be equal to 72 by 12. So since 12 into 6 is equal to 72, so it will be x is equal to 6. So we have arrived at a conclusion that x is equal to 6. So 3x is equal to 18. Okay, and 4x is equal to what? This much, because 3 into 6 is equal to what? 18, right? And 4x is equal to what? 4 into 6 is equal to 24. So 3x is equal to 18 and 4x is equal to 24. So the two numbers will be 18 and 24. So their LCM will be what? So according to the question, their LCM will be actually 72. LCM of 18 and 24 is equal to 70. So let's go forward with problem number 2. So find two numbers whose GCD is 10 and their product is 1000. So what is GCD? So G stands for greatest, C stands for common, and D stands for divisor. Okay, so all the numbers that divide what? Those two numbers, and they are common, and then we'll see for the greatest one among them. Okay, so find the two numbers whose GCD is 10. So given that GCD is equal to GCD of AB, so let those two numbers be what? AB is equal to 10 and their product, so A into B is equal to 1000. Okay, so we assume that those numbers to be A and B. So given this, so A is equal to what? 10 into some P, and B is equal to 10 into some Q, since their GCD is 10. Okay, so since it is a GCD, so since it is a common divisor, so basically it divides both A and B. So let the remainder be what? P and Q. Let the divisor be what? P and Q when divided by 10. Okay, so P and Q are co-prime. Okay, so GCD of PQ will be what? 1. So given that AB is equal to, that is product of those two numbers is equal to 1000. So 10P into 10Q is equal to 1000. This is what given to us. So Q will be 10. Because what? So this implies that 100 PQ is equal to 1000. Right. So by going on for PQ only, what we are left with is 1000 by 100. So it will be nothing but 10, right? So since P and Q are co-prime and their product is what? 10. So the only possible values for P and Q are 1 and 10. Okay. So therefore the numbers are A is equal to 10 into 1 is equal to 10. B is equal to 10 into 10 is equal to 100. Okay. So the two numbers are 10 and 100. Okay. So let's go forward with problem number 3. So if the GCD of two numbers is what? 14 and their product is 392. Okay, so GCD, that is the greatest common divisor. So greatest common divisor, okay, of the two numbers is what? 14 and the product. So GCD of AB is equal to 14, that is given here, and AB is given as 392, right? So let So since 14 is there, so let A is equal to what? 14P. We can assume this, and B is equal to 14Q. And P and Q are co-primes, right? That is their GCD is equal to 1. Greatest common divisor is equal to 1. So basically 14P into 14Q is equal to what? 390. So this implies that PQ is equal to 392 by 14 into 14. Okay. So it will be what? So it will be 2, right? So this will be equal to 2. Okay. So basically what? GCD is equal to 14, AB is equal to 392. This is given to us. So AB by, so this will be what? 392 by 14 is equal to 28. So LCM will be 28. Okay. Since PQ is equal to 2, what we want to evaluate? We want to evaluate the LCM. Okay. Here we have evaluated PQ. Okay. So PQ is equal to 2. So how to evaluate LCM? LCM is equal to what? AB, that is the product of the two numbers by their GCD. So 392 by 14 is equal to 28. So LCM of the two numbers will be 28. So let's go forward with problem number 4. So the LCM of two consecutive even numbers. So how we can actually get two consecutive even numbers? Okay, abstractly I am trying to say. Okay, so let one number be what? 2x, and the other number will be 2x plus 2. If you want to take two consecutive numbers, you can actually also take 2x minus 2. But for the sake of what? Ease of doing problem, we will take these two as the consecutive even numbers. So what we want to calculate is, we want to calculate that the LCM of two consecutive number is this much. If this is given to us, then we need to find the two numbers. Okay, so let's assume the two consecutive even numbers is a and a plus 2. So here we have assumed a and a plus 2. So we can actually assume this. How? If we assume a to be even, so we have assumed a to be even. Okay, and here also a is even. So the LCM of two consecutive even numbers is just the product of the numbers because they are co-prime. Okay, so therefore a into a plus 2 is equal to, this is given, so a square plus 2a minus 168 is equal to 0. So we need to solve this quadratic equation. So how we can actually solve a quadratic equation? So the question is how to solve a quadratic equation. Okay, so in order to solve a quadratic equation, what you need to do? You need to do what this means, right? So quadratic equation is nothing but a quadratic expression equated to 0. Okay, so what is a quadratic expression? So a expression of this form, that is ax square plus bx plus c is equal to 0. Okay, plus c actually. Okay, this is called a quadratic expression. Quadratic expression. Okay, so here a must not be equal to 0, b, c, these are all constants. Okay, and equating it to 0, what we are left with is quadratic equation. Okay, that is what a quadratic equation is. How to solve it? So we have a formula, that is the Sidracharya formula. That is, if this kind of equation is there, how we can evaluate it? So it will be x is equal to minus b plus or minus root over of b square minus 4ac whole by 2. Okay, so this will be equal to what? So in this case, it will be minus b is equal to minus 2 plus or minus root over of b square, that is equal to 4. So minus 4 into a, that is equal to 1, into c, that is equal to minus 168. So it will be plus 168 whole by 2 into a, that is equal to 1. So the answer will be what? So it will be minus 2 plus or minus. Okay, so what we have there inside the bracket, inside the square root, plus 4 plus, so 168 into 4. Okay, so let's see what 168 into 4 is. So it will be 160 into 4, that is equal to 640 plus 8 into 4 is equal to 32. So 672. So 672. So it will be 676 whole divided by what? Whole divided by 2. So this will be the what? 2 roots, that is equal to, one root will be 14 minus 14 and one root will be 12. Okay, so a is equal to minus 14 is not possible. Okay, because we are looking for what? Positive even numbers. Okay, So A is equal to 12 will be the correct answer. Okay. So the numbers are A is equal to 12. So A plus 2 will be what? 14. So the next consecutive even number is actually 14. So the two numbers are 12 and 14. So find the first 6 multiples of 6. Okay. So first 6 multiples of 6 can be found by multiplying 6 by the numbers from 1 to 6. So here they are. So 6 into 1 is equal to what? 6 into 2 is equal to 12. 6 into 3 is equal to what? 18. 6 into 4 is equal to 6 plus 6 plus 6 plus 6, that is 24. So 6 into 5 is equal to 30. That is 6 plus 6 plus 6, 6 plus 6 plus is equal to 30. So this way, by adding 6 times, we are left with 36. So the first 6 multiples of 6 are 6, 12, 18, 24, 30, 36. Okay. So find all the factors of 90. Okay, so you have 90. So let's try to go forward from 1. So 1 divides, right? So 2 divides because it is an even number. Okay. And 3 divides because adding all the digits, we are left with 9. And 3 divides 9. So 3 is a factor. 4 is not a factor because 4 divides 80, right? So 4 divides 80. And we have only 10 left out there from 90. So since 10 can't be divided by 4, so we can say 4 is not a factor. 5, yes, because we have a 0 at the unit place. Okay. What about 6? So we can actually divide it by 6 because 15 into 6 is equal to 90. So since 15 into 6 is equal to 90, we are left with what? 15 right here. Okay, so 5 can divide what? 90, right? So how? Because 18 into 5 is equal to 90. And 3 can divide 90 how? Because 30 into 3 is equal to what? 90. And 45 can actually divide 90 because 90 by 2 is equal to 45. So let's go forward. So can 8 divide it? No, because 8 can divide 80 and the difference is 10. Okay, so the remainder won't be 0. So can 9 divide? Yes, 9 can divide. How? Because 9 by 10 is equal to that much. So can 12 divide? 13 divide? No. Okay, so can 15 divide? Yes. Can 18 divide? Yes. 1, 2, 3, 4, 5, 90 itself also. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there are 12 factors listed as these, which actually divide 90. So starting with number 1, factors is equal to 1, factors 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 5, then 1, 2, 3, 5, 6. Okay, so divide 90 by 9, which gives 10 with no remainder. So 1, 2, 3, 5, 6, 9. 1, 2, 3, 5, 6, 9, 10, right? So that way 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 factors. Okay, and then we have other two, that is 12 factors in total. Okay, which actually divide 90. So let's go forward with problem number 7. So what it tells us to do is, it tells us to arrange the following integers in ascending order. So what is ascending order? That is from lowest to highest. So it isn't asking us to what? Go forward from last to first or from highest to lowest. It tells us to go from lowest to highest. So it will be what? So let's see which among these is actually the lowest one. So as I can see right here, 850 is the lowest, then 860, 870, right? Then 890, then 910, right? Then 910, and then 930, right? So this will be the ascending order. So compare all the given numbers and identify the smallest one. So the smallest number is 850. Okay, so move on to the next smallest number. Among 870, 910, 930, the next smallest number is 870. So continue this process to arrange the remaining numbers. So next 890, then 910, and finally 930. So arranged in ascending order: 850, 870, 890, 910, 930. So let's go forward with problem number 8. So a basketball game started at 6 p.m. and ended at 7:30 p.m. So how long did the game last? Okay, it will be 7:30 minus 6, right? So this will be what? 1 hour and 30 minutes, right? The answer will be 1 hour 30 minutes. So find the difference between the end time and start time. So 7:30 minus 6, that is equal to 1:30. So it lasted for 1 hour 30 minutes. So Dravid earned what? 8 rupees per hour. So how much money did he earn after 7 hours? 7 into 8, it will be the answer. So 8 into 7 is equal to what? 80, 56. Okay, so this will be 56. So multiply the hourly rate by the number of hours. So 8 hour into 7, 8 rupees into 7 hour is equal to 56 rupees. So Dravid earned what? 56 rupees after working for 7 hours. So if one half of a number is 8 less than 2/3 of the same number, then what is the number? So let the number be x. So according to the problem, 1 by 2x is equal to 2 by 3x is minus 8. So 3x is equal to 4x minus 48. So x will be 48. So the number is actually 48. So number 1 multiplied by 3 by 4 gives a result of 27. So what is the number? So let the number be y. So y into 3 by 4 equal to 27. So y will be 27 into 4 by 3. That is equal to y is equal to 36. Okay. So 3/5 of number is 12 more than 1/4 of the same number. So 3 by 5z is equal to 1 by 4z plus 12. Okay, we can derive this conclusion right from here. So multiplying everything by 20. So we are left with z is equal to 14 to 7. So z will be 34.29. The number is approximately 34.29. Okay. Now let's go forward with problem number 13. So the smallest multiple of 7 which leaves a remainder of 4 when divided by 9, 11, 13 is what? So find the numbers first which leave a remainder of 4 when divided by 9, 11 and 13. So 9 minus 4 is equal to 5, 11 minus 4 is equal to 7, 13 minus 4 is equal to 9. Okay, so the LCM of 5, 9 and 7 is equal to 315. So the number which leaves a remainder of 4 when divided by 9, 11, 13 is what? 315 plus 4 is equal to 319. So however 319 isn't a multiple of 7. So we continue adding the LCM 315 until we find a number that is also a multiple of 7. So upon trying 319 plus 315 is equal to 634. 634 plus 315 is equal to 949. Okay, both are not divisible by 7. So the smallest multiple of 7 that first fits the criteria is 749. Let's see problem number 14. So if 2 by 5 of a number exceeds its 3 by 8 by 7, 6, then what is the number? So let the number be what? W. So according to the problem, 2 by 5 W is equal to 3 by 8 W plus 6. So multiplying everything by 40, that is the LCM. So 16W is equal to 15W plus 240. Okay, so W is equal to 240 because 16W. So how to solve from this to this? So let's try to negate minus 15W in both the sides. So 16W minus 15W, right, is equal to 15W minus 15W plus 240. So what we can see here, this is equal to actually 0 cumulatively. So it will be equal to what? W is equal to 240. Okay, we can conclude this. So the number is what? 240. So what is the least value of x? So that the number 8 into 50 to 15 becomes divisible by 9. Okay. So for a number to be divisible by 9, what we want is, we want all sum of all the digits of a number. Okay. So what we will do, we will sum all the digits and then what we do, we divide it by 9. If it is divisible, then the number is divisible. So by doing this, what we need to do is, okay, so it will be 21 plus x. So 21 plus 6 will be 27. That is actually divisible by. Okay, so this is actually a whole number. Okay, this position is not given to us. Don't take it as multiplication. This is not multiplication, not multiplication. Okay, so what should be the value of x so that the whole number is divisible? Okay, so find the greatest number 23a 68b which is divisible by 3 but not divisible by. Okay, so the basically all the digits should be, so sum of all the digits should actually be divisible by 3 and should not be divisible by 9. That is what we want to calculate. So 2, 3, 9, 6, 5, 8 is the greatest number which is not divisible by, which is actually divisible by 3 but not by 9. So how? So 2 plus 3 plus 8 plus 6 plus 8 plus b. So this is equal to what? So a plus b is equal to a plus b plus what? So this will be 5 plus 6 plus 8. So this is equal to a plus b plus 6 plus 5 is equal to what? 11 plus 8 is equal to 19. Okay. So basically if a is equal to what? A is equal to 9 and b is equal to what? So b is equal to 5. Then their addition will become what? So it will be 9 plus 5 is equal to 14. So 14 plus 19 is equal to what? 33. That is actually divisible by 3. But as you can see, 33 is actually not divisible by 9. Okay. So 33 is not divisible by 9. Right. So let's go forward with 17. That is, if a 9-digit number, that is this, is actually divisible by 72, then the value of x minus y is equal to 40. So if this is divisible by 72, then this must be divisible by 8. So the last 3 digits will be divisible by 8. So 7, 8y is actually divisible by 8. Okay. So what should be y? So 7, 8y by 8. Okay. So it will be what? Y is equal to 4. So y must be 4. Otherwise, it won't be divisible. So divisibility of 9 is equal to. So sum of all digits must be divisible by 9, because if it is divisible by what? 72, then it must be divisible by 8 and 9 both. Okay. So summing all of them, what we are left with is x must be equal to 6. Okay, since y is equal to 4, so we can replace 4 here, right here. So up to this, we have arrived at the conclusion that number must be 7, 8, 5, x, 3, 6, 7, 8, what? 4. Okay, so this must be 4. So we want to now just evaluate this one. So divisibility of 9 is equal to what? Sum of all the digits must be divisible by 9. So this implies x is equal to 6. So x minus y is equal to 6 minus 4 is equal to 2. So let's go forward with rule number 18. So if the 9-digit number, that is 8, 4, 7, 5, 6, 3, 9, a, b is actually divisible by 99, then what is the value of a and b? So if a number is divisible by 99, then it will also be divisible by 9 and 11. So 8, 4, 7, 5, 6, 3, 9, a, b. So this is divisible by 11. So the difference between the sum of odd places digits and sum of even places digits from right hand side should be 0 or the factor 11. Okay. So divisibility by 9. So sum of digits should be divisible by 9. So sum of digits is equal to what? So this will be 42 plus a plus b. So a plus b should be 3 or 12. So difference between odd places digits and even places digits. So it will be what? So b minus a should be 4. Okay. Because b plus 9 plus 6 plus 7 plus 8 minus a plus 3 plus 5 plus 4 is equal to b plus 30 minus a plus 12. So a plus b is equal to 12 and b minus a is equal to 4. Let's go forward with problem number 19. So how many numbers are there from 300 to 650 which are completely divisible by both 5 and 7? So LCM of 5 and 7 is equal to 35. So the numbers divisible by both 5 and 7 are multiple of 35. So between 300 and 650, we have 10 multiples of 35. They are 315, 350, 385, 420, 455, 490, 525, 560, 595 and 630. So let's go forward with problem number 20. So arrange the numbers 3 by 4, 2 by 5, 7 by 8, 5 by 6 in ascending order. So 3 by 4 is what? 0.75. 2 by 5 is equal to 0.4. 7 by 8 is equal to 0.875. 5 by 6 is equal to 0.833. So from ascending order, that is from smallest one to the largest one, this will be the largest one, this will be the largest one, and this will be the second largest one, and this will be the third largest one, and this will be the first one. Okay. So 2 by 3, 3 by 4, 5 by 6 and 7 by 8 are the perfect ascending order for those sequence of numbers. Okay. So I believe we have done a very variety of problems. So that's all for now. Thank you.